Atlas Boeing 767 Cpat review of AFDS Autopilot Flight Director System and MCP Mode Control Panel.
Boeing 767 utilizes three FCCs, flight control computers, a thrust management computer, TMC, the auto throttle system, two FMCs, flight management computers, and IRS, inertial reference systems. The MCP is the mode control panel. The TMC, thrust management computer, provides auto throttle operation throughout the flight. It is supported by the CDU, the EFIS control display unit, and the electronic flight instrument system. The FCCs, the flight control computers, combine auto throttle and autopilot operation. The three computers are labeled left, center, and right, and each provides signals to the respective autopilot hydraulic servos. When LNAV is selected, the FMC provides lateral control signals. When VNAV is selected, the FMC provides pitch and thrust control signals. For most flights, the autopilot controls the elevator and the aileron. In multi-autopilot approaches, the rudder is added to maintain runway centerline. An illuminated bar in the MCP switch represents a requested mode. The active and armed modes are indicated by the FMA, the flight mode annunciator of each ADI, attitude director indicator. The autopilot can be disconnected by control wheel switches or the bar on the MCP. The autopilot disconnect light and ICAS autopilot disconnect message will appear and the siren will sound. The siren can be silenced by selecting the autopilot disconnect switch a second time. Flight director steering indications display when the flight director is selected on. They also display if the flight director is selected off and the go-around switches are pushed, the airspeed is greater than 80 knots, and the flaps are not up. In this case, the flight director can be removed again by cycling the flight director switch to on and back off. The FMA displays on both ADI when either flight director switch is on. A failure in pitch or roll will result in the respective steering bar disappearing. During autopilot operation, failures affecting the active mode annunciator on the FMA will result in the autopilot remaining engaged in an attitude stabilization mode. An amber line will appear through the mode annunciation. The autopilot light will be illuminated in amber, and the ICAS message amber ICAS message autopilot will appear. For failures affecting all autopilot modes, the autopilot disconnects and an oral warning sounds, as well as the autopilot disconnect light and the ICAS message autopilot disconnect. Thrust management computer controls the auto throttles with manual inputs from the MCP or automatic inputs from the FMC while in VNAV. The TMC calculates thrust limits and settings or follows the FMC thrust settings. It detects and transmits autothrottle failures and actuates the thrust levers. The autothrottle mode is controlled from the MCP and the TMSP, the thrust mode selector panel. The autothrottles can be disconnected with the autothrottle arm switch on the MCP or the thrust lever autothrottle disconnect switch. Autothrottles disconnect when there's a fault in the autothrottle mode or reverse thrust levers are raised idle. The autothrottle disconnect light and ICAS autothrottle disconnect message display when an autothrottle is disconnected. The flight mode annunciator or FMA is displayed on the ADI. There are 4 positions, and from left to right, they indicate the auto throttle mode, the pitch mode, the roll mode, and the AFDS status. An active mode is displayed in large green letters on top. An armed mode is displayed in small white letters on the bottom, except takeoff on the ground and go around in flight. The following modes become active when selected: flight level change, VNAV, thrust, speed, heading hold, heading select, vertical speed, and altitude hold. The following modes are armed before activating: LNAV, LOC, and approach. These 3 modes can generally be deactivated by selecting the switch again before they have activated. That was really cumbersome. Let me say that again. If LNAV, LOC, and approach have been armed, they can be canceled by pushing the button a second time before they become active. Generally, any mode can be canceled by selecting another mode. The exception is after localizer and glide slope capture, the approach mode can only be canceled by selecting the flight director and autopilot to off or pushing the go around switches. There are 2 auto land status annunciators which provide the status of the AFDS for auto land and rollout. 3 IRS inertial reference systems are installed. They provide attitude and heading, as well as position, track, ground speed, wind direction and speed, and acceleration. Individual mode selectors control each IRU. The EFIS displays contain 2 NDIs, 2 HSIs, 2 control panels, and 3 symbol generators. The HSI provides a map with position in relation to lateral and vertical track. The 3 signal generators work as follows. The left provides data to the captain's EFIS. The right provides data to the first officer's EFIS, and the center is a backup. Each has its own ILS receiver and radar altimeter. The illuminated bar lights on the MCP indicate selected or armed, not active modes. Active modes are only viewed on the FMA. Flight director switches enable the respective display of flight director bars. Either flight director switch on results in the FMA indicating on both ADIs. With the auto throttles armed, no auto throttle operation occurs until a mode is engaged. Speed selector adjusts the selected speed for the following modes: MCP speed, filch or flight level change, VNAV speed. The selected speed appears when one of these modes is engaged. The select button toggles between airspeed and Mach. The bank angle selector limits roll guidance in the heading select mode. Auto limits are based on true airspeed. The heading hold button maintains the existing magnetic heading, or if in a turn, rolls wings level and maintains that heading. The autopilot command switch, one must be disengaged before another is engaged. Thrust switch for the auto throttles puts the auto throttles in N1 mode. The N1 displays on the FMA, and the power is set by the thrust management computer as displayed on the N1 gauges. It controls thrust subject to max speed limits, and the available thrust limits are reduced takeoff, takeoff, go around, reduced climb, climb, cruise, and continuous. Selecting the speed switch controls the selected airspeed through auto throttle operation. If the speed switch is pressed after takeoff above 400 feet radio altitude, thrust reference changes from takeoff to climb. Speed is not normally selected after takeoff. When VNAV is selected, this allows the FMC to control vertical flight path and airspeed. It requires that the necessary performance information and cruise altitude are entered in the FMS. With VNAV engaged, indicated airspeed and Mach window is normally blank. The FMC drives the airspeed cursor on the ADI, and the crew can change the FMC target speed through the FMC CDU or through the MCP indicated airspeed or Mach selector by engaging speed intervention. In VNAV climb, the auto throttle sets the FMC thrust and the AFDS sets the FMC target speed using pitch. The MCP selected altitude constrains VNAV altitude for climb or descent. In VNAV, the aircraft will level off at the MCP altitude or the FMC altitude, whichever is reached first. This means that proper MCP altitude selections must be made to ensure correct altitude alerting. In VNAV cruise, the AFDS holds altitude. Auto throttle adjusts to hold target airspeed. In VNAV descent, the auto throttles go to idle, and the AFDS holds FMC target airspeed using pitch. VNAV can be engaged by selecting vertical speed or altitude hold. VNAV can be disengaged by selecting vertical speed or altitude hold, selecting go around, or selecting speed, thrust, flight level change, or when glide slope is captured. Filch or flight level change is used to climb or descend with a combination of automated thrust and pitch control to maintain airspeed in the indicated airspeed or Mach display. Flight level change is not an FMS mode. With the MCP altitude set higher, the auto throttles will advance the throttles to climb at the indicated Mach. With the MCP altitude set lower, the auto throttle will reduce throttles to descend at the indicated airspeed or Mach. On the FMA, filch in the auto throttle window, speed in the pitch window. After takeoff above 400 feet RA, thrust reference changes from takeoff to climb. Not sure what that means. If no active speed mode is selected, when filch is selected, the current airspeed appears and the cursor sinks to allow current speed to be the filch target speed. Once filch is engaged, indicated airspeed Mach value can be changed with the speed selector. With filch engaged, if a higher altitude is selected, the auto throttle advances thrust to the M1 limit. The AFDS pitches to the selected indicated airspeed or Mach. When a lower altitude is selected, the auto throttle sets idle thrust and AFD pitches to the selected indicated airspeed or Mach. The heading select mode turns the aircraft to the selected heading, restrained by the bank limit selector. Commands a turn in the same direction as rotation of the selector. Upon localizer course capture, the heading bug and the readout will display the ILS front course heading. In LNAV, the navigation is driven by the FMC. With LNAV armed, the FDS will capture and track the active FMC route. This route can include SIGs, STARS, and instrument approaches. In order for LNAV to engage, the FMC must be active. The FMC mode must be active, and the aircraft must be within 2.5 nautical miles of the active route segment, regardless of its heading. If greater than 2.5 nautical miles from the active FMC route, the heading must intercept the route before the next active waypoint. LNAV can be disengaged by selecting the heading selector or the heading hold. It automatically disengages when an armed localizer capture occurs. At the end of an active route or a route discontinuity, LNAV will automatically resort to heading hold without a change in FMA display. This normally appears as a CDU scratchpad message. The vertical speed mode is selectable when the altitude hold is active with the MCP selected altitude. A new MCP altitude does not need to be set. Vertical speed can guide the aircraft away from the selected altitude. Vertical speed is inhibited after glide slope capture when the autopilot is engaged. Altitude hold. Pressing altitude hold will cause the aircraft to hold the current altitude. Altitude hold is automatically engaged when the aircraft arrives at an MCP altitude. Selecting another pitch mode will disengage the altitude hold. The localizer switch arms the ILS to intercept and track a localizer. The AFDS will intercept the localizer from heading select or LNAV. Capture will vary by closure rate and intercept angle, which can be up to 120 degrees. When capture occurs, the heading window slews to the inbound localizer course. The AFDS would command up to 30 degrees of bank, regardless of the bank angle selector. LOC is a single autopilot function. The approach mode will capture and track the ILS for approach, landing, and rollout. It remains engaged until the go-around buttons are pushed or both flight directors and autopilots are selected off. The localizer must be captured before the glide slope capture can occur. It is best practice to engage the localizer first, then engage approach when in a position to capture the glide slope. The AFDS captures the glide slope at less than 1 dot. If the ILS transmitter fails, the aircraft continues on an inertial track. There's an amber line through the affected FMA, and the flight director command bar is removed. That concludes AFDS and MCP Cpat review.